8th grade lesson 14.1 is scatter plots and association. So we're going to go ahead and get into looking at scatter plots and how to read them. I think you'll find this all pretty easily falls into place. Let's get started. Okay, and before we get started looking at scatter plots, let me go ahead and review a vocabulary word with you and then give you a new one. Bivariate data, by meaning two variables, variate is a set of data with two variables. You've been seeing that frequently as x and y, and we graph the x this far on the x turn and go this far on the y. We graph those on a coordinate plane. You're going to see that coordinate plane come back. And a scatter plot is basically a graph, something graphed on a coordinate plane with points plotted, and they'll show a relationship between two sets of data. You're not going to see everything falling into nice straight lines like we have in the past. They're going to be scattered on there, but you should usually see a pattern, and that's what this is all about. So let's say we have a math test coming up, and several people study for a certain amount of hours, and then we look at their test grade. How many hours did you spend studying for this test? Which could be a question I ask. And then the teacher records the number of hours each student studied and the grade the student received on the test. And before we go even looking at the data, what prediction can we make about the relationship between the number of hours spent studying and the test grades? You might make the prediction of those who studied more will did better on the test, maybe. And let's have a look and see how our scatter plot turns out, whether it looks that way. So bivariate data, again, means you've got two sets of data, the amount of hours that were studied and the grade that they received on the test. We'll call those XYs because we're going to use a graph. X number line being the hours spent studying, the Y number line being the test grade. They want us to make a scatter plot, graph the hours spent studying as the independent variable and the test grades as the dependent variable. So we're just going to use these as our coordinates. 0 on the x turn, 75 on the y. 0 on the x turn, 75 on the y, mark it. So doing a scatter plot just means graph them all. 0.5 on the x, so half on the x turn, 80 on the y, half on the x and 80 on the y. 1 on the x, turn 80 on the y. 1 on the x, turn 80 on the y. And we're just going to go through 1 and 85, 1.5 and 85, 1.5 hours and 95, 1.5, oh, sorry, I already did that one. 2 hours, and that person studied 2 hours and got a 90. This person studied 3 hours and got a 100%. This person studied 4 hours and got a 90%. And I guess they call it a scatter plot because your dots kind of scatter all over, but you generally, like I said, you will generally see a pattern. And we see this pattern of it trending upward. The more hours studied, the higher the score went, with the exception of this guy. Struggled a little on something. But what trend do you see in the data? For the most part, I see the trend in the more hours studied, the better they did. Okay, for the most part, the more hours studied, the better score was received or earned, or however you want to word it. Do you think the grade associated with studying for 10 hours would follow this trend? Our current trend goes upward, 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 upward. If they went to 10 hours over here, would we see it upward, upward, upward over here? If that's what they're asking us, then my answer is going to have to be no, because the maximum score you can get on this test is 100, right? So we might see something like that. If that's what they're asking, I'm not going to see this trend continue further up past the 100 because that's as high as you can get. So that would be my answer if that's their question. If their question is more like, well, would you see 10 hours? Would you see this all up in the higher range? Then I would say yes, 10 hours. I would expect most of these to be up at the highest score. But I'm making the assumption that the question they're asking has to do with this pattern continuing in this almost like a line this way, in a slope that way. So my answer I'm going to go with is, if that's the question they're asking, then no, we're going to see that top off at 100 because that's the highest score you can get. And I went ahead and drew it out as well. So I said, no, the data would top off at 100. And then I drew it. It's, the more hours you spent studying, the higher your score got. But until you hit 100, until the people hit 100, then they can study hours and hours. That 100 is the highest score possible. A few more vocabulary words on this topic is a cluster. In a scatter plot, sometimes you'll see a set of closely grouped items, like this is a cluster and this is a cluster, because they're all kind of closely grouped. And every now and then you'll see an outlier, kind of a loner out there, a data point very different from the rest. That guy right there is an outlier. This is data, by the way, that is the amount of time in between eruptions of Old Faithful, the geyser. This is the in-between times that it erupted. And then this is the amount of time the eruption lasted. So you can kind of look at this and go, if there was a longer time between eruptions, then you have a longer eruption releasing the pressure. If there's a shorter time, then the eruption is shorter generally. So this guy was just short time between its eruption and had a long eruption for whatever reason. It's nature. It has its odd things that happen every now and then too. But you end up, when you plot things out, you end up seeing patterns, and that's what this whole lesson's about. And finally, the last bit of information that this covers is association. Like, what do you notice in the pattern? So an association describes how the sets of data are related. What trend are you seeing? What's the sort of pattern that you're seeing? A positive association like this means that both data sets increase together. It sort of leads to like a positive sloped line, right? You remember positive slopes lean forward. You can see the pattern kind of goes that way. Both data sets increase together. When this side goes up, so does this side. A negative association, you could see this one here. It's like a negative slope of a line. It means that as one data set increases, the other decreases. And no association, you can see right here, would be if you see no noticeable pattern really at all. It's just really scattered. There's not really a noticeable pattern, so that there's no relationship between the two data sets. So positive association, you see a positive slope leaning forward. Negative association, you would see a negative slope leaning way back. And then sometimes there's no association. There's no pattern that you see. That's all this lesson is. It's just recognizing those things and just introducing that vocabulary. I think that you'll have an easy time with this.